Here is daily code problem. Remove duplicate letters 316, right? And the date is 26/9/23. You are string. Remove the duplicate letters from that every letter appears only once and once. Okay. They could have actually said that remove the duplicate letters and make sure that the result is lexicographically smallest among all the possible options. So how do you get to do this? Another question. So for that, let me take you to the example. So first example, BC. The answer is ABC, right? Because this is the lexicographically smallest, and none of the characters just have any repetition. Other could answer could be BCA, but you know why that is not an answer because it's not the lexicographically smallest. But that's the way that we have to move on. We have to consider BC as a particular option. We have to consider ABC as a particular option, and then try to minimize this. But how do you get to do this? Okay, it's not something like I'm going over each possible that and then getting to this. Because look, one of the way of getting a subsequence is using bit mask, right? But 10 raised to 2 raised to the power x, okay, where x is the number of letters, and even if that not, you say that okay, x. You don't have to really go about number of letters you because there are 26 letters only, and I say yeah, 26 letters only, but you have then 26 factorial permutations of those 26 letters, and any one could be the scenario. Okay, but let's not go in there, and let's just try to figure out how we can do this. So first of all, the goal is clear that we want non-repeating characters and lexicographically smallest as possible. So what I will do is that uh, this is a concept of basically having, let's say, z is coming and then a is coming and b is coming, and yeah. So and like now, like z is good as far as z is concerned, but after z you get a. So you would not like to have this kind of a combination. You would like to have like, okay, let me start with a, not z. And you can say that if you have z extra over here, like z is also present after this a, so it's better to have az instead of having za. It's better to start your string with abz instead of having it zab, right? So how do you can say that okay, I'm gonna pop in and not taking this z and remove this z and starting off with a. I can only say that if the last occurrence of z is there some, it has some of the occurrence after the a. Okay, so my last occurrence should be greater than this particular index, so I can say that okay, I'll get this in future. So you cannot take it now and take it in future. So that's why I have a lid for every 26 characters, the last index when they occur. And then I go like starting from the string. Okay, I go on b and I say okay, let's take b. I go on C, I say let's take C. Why I don't conflict it? Because okay, C is greater than B, so why to conflict, right? It's not conflicting. Conflicting is when A comes after C. This is a conflicting because you want to have like A, B, A, C, not C A. Okay, C A is not a good pair because you are decreasing. Okay, you want to make it increasing so that it's lexicographically small. So then you say okay, now C is on the top. Do I have any C after this? So I can skip taking C over here and I can somehow make it like BA and then take C, because AC is good for me. Even if it's not AC, it is something like ADAC or ADBC, whatever. But having C after A is very good. Okay, so I say yeah, you have C. So again, my on top my is now like B. I can remove B as well, because I'll get B again. I know, and you get the B next. The last occurrence was greater than A. So that was the thing. Even if it was ACB, I was ready to go for this because it's far better than BCA. Okay, have A at the first thing. So that's what we need to do. We use stack for this thing to check what is on our top, what is your current thing, and do I remove the top to make the current thing on the top, and I'll take the top afterwards, like because the last index is something which is greater than the current index, so I can always have it. So the algorithm is like calculate LID, then iterate using a set. Okay, using a stack, or iterate and maintain stack, I would say. And then you check the condition which is very famous in like stack things, monotonic stack, that okay, stack dot size, and if stack dot top is greater than current index. I would not like it. I like to pop it. Okay, it's dot pop. But just a condition comes up that before popping, you just check that okay, LID should be there. Like LID of the top should be greater than I. This is somehow the algorithm or pseudocode looks like when you pop it and then you push it stack dot pop and you say stack dot push the current character which is a of I, and yeah, this is the whole thing. And you return like get the stack as your string, so you take out stack to string. Okay, there are a couple of ways for that, but yeah, somehow you can do this obviously. And now the only thing to mention here is that okay, what if you got A, B, C, and again you got A, like like you was moving as A. Okay, take it. C, take it because it's greater than my top. Okay, I have a problem when top is greater. Okay, so it's increasing. Take it, and then C, B, and now you see. Okay, this is something not. This is something conflicting. I would like to have it BC. I can have it if C is afterwards. Okay, let's say C is not there, so you have to go with C and then B because C is not there. Like this condition is false, so you don't pop it. You push just B. Then you see A again. Do you take it? Like, look, BA is not good. I would like to see whether you have some occurrence of B over here. You don't. Okay. Current character A of I is something A which has already occurred, but you do not check it. You check that okay, what is on top? B is on the top. Is this a combination valid? Good. It's not a good combination. But do I have any occurrence of B? No, you don't have. So I have to go and push A. Do you need to push A? No, you need to have only unique characters. You already have A. So if already visited what AI, oh, continue, man. Like you have already visited AI. Continue. And when you visited you made sure that okay it's fine as far as that is concerned, because while before pushing I need to make it as fine as it is possible. So I remove everything that can be removed before AI, that should be removed before A of I. So A of I is very good. I know that. So I don't, if it is already visited, if it is already in the stack, then yeah, better not to consider that. If it is already in the stack, that is the main thing. So when you pop it from the stack, visited becomes equal to 0. When you push it into the stack, visited becomes equal to which visited? Visited of top, because you are popping is dot top. So this I think I need to make sure a bit more clear about that. When you push it, you push the current character and visited of AI equal to obviously 1. But when popping, visited of stack top equal to 0. Chalo. So this is the whole code which I have written LID, calculated LID, and then stack and visited just to maintain during the iteration 0 to n, visited continue. But this is the main part. You got your top conflicting with your current character. You see the top is present after the current character. So let's remove the top, make it visit 0 and st.pop and push the current character. Like while this is conflicting, you pop it and then you push it and then you make it visited the current character. If it's already there, you don't, yeah, you can just continue. And this is the way of getting stack to string. You got everything into string and then you reverse it because of the order of stack, right? LIFO, FIFO, leak for right. Oh yeah, I think that's fine. And I have already submitted just, but you can do this again. Now you can see it's pretty decent. And okay, guys, that's all. Bye.